difference in double angle identities today. Previously, you were asked to find exact values of sine 30 and tan pi over 4, and you came up with special triangles, or we did the unit circle and you could just pull the values off, right? If it was cos, you picked the x's. If it was sine, you picked the y's. If it was tan, you did y divided by x. If it was cotan, you did x divided by y. If it was secant, you flipped cos, and if it was cosecant, you flipped sine, right? Now we're going to use all of those, but there's only certain ones that fall directly on that unit circle, right? So up till now, if I said find the exact value of something, you knew that that has to come off the unit circle, because that was the only way you get exact values. If it was like sine 66, you could go sine 66 in your calculator, get a decimal, give me an answer, right? But if I wanted an exact value, it had to be one of the angles off your unit circle or the coterminal angles off the unit circle, correct? Well, with some angles, some indifference, and double angle identities, I can ask you for ones that are not directly off the unit circle, but you can use the angles off the unit circle to get them. So, huge hint here. When it says find the exact value of sine 75. Exact value is a huge hint, most of the time, that you're pulling your answer off the unit circle. So that's where we get our exact values from. However, sine 75 is nowhere to be found on that unit circle, right? There's no 75 on the unit circle. Are there any values that I can add or subtract together that would get me 75, though? 30 and 45, right? 30 is on the unit circle, 45 is on the unit circle, but 75 is not on the unit circle. So I'm going to use the sine addition formula. If you look up at the very top of your, well, it's kind of in the middle, the very top of the new ones we're looking at, sine A plus B equals sine A cos B plus cos A sine B. What's great is you don't have to have them memorized. So it's sine A plus B, it's alpha plus beta anyways, equals sine A cos B plus cos A sine B. Such bad handwriting on this thing. Okay? You have to spot that sine 75 can be an adding and subtracting one. That's what you have to be able to spot. But the key word in there is exact value that gives you a hint you're going to be using those formulas. So sine 30 plus 45, or we could go sine 45 plus 30. It doesn't matter, right? They both add 75. So I'm going to go sine 30 degrees plus 45 degrees. Now, what do I find some people do, which goes really terribly badly, is they'll go sine 30 plus sine 45. They like distribute it in and think that that's right. It's not. The formula is sine A plus B is sine A cos B plus cos A sine B. You have to fill it into this formula. You can't just distribute the sine in. Don't do that. Don't be that person. So wherever there's an A, I'm going to put in a 30 degrees. Wherever there's a B, I'm going to put in a 45, right? They're in that spot. So I'm going to get sine of A, so sine of 30 degrees, cos of B, so cos of 45, plus cos of A, so cos of 30, sine of B, so sine of 45. And technically, this is sine 75, right? So that's what we're finding. So most people get to here and then they start crying, or they start putting in decimals, or they just are sad. You know the answers to this. What's sine of 30? 1/2. Go to your unit circle, pull the y off. So I feel like half time I'm being punked on this thing. Okay, 1/2. Cos 45. Do you want to know where everyone goes wrong on this? And I warn you, and then if it's a written response question, perchance maybe, you do it wrong. Sine of 30, do you know how many of you write sine 1/2? All of you, actually. Don't be that person. Sine of 30, I take sine of 30, I hold it in my hand, I throw it across the room, I grab off a 1/2 off the unit circle, and I put it in its place. You're not left with sine 1/2. Everyone does that. Don't do that. Everyone does that. If you were that person, stop yourself. If you weren't that person, you might be that person next time, so don't do that. So sine of 30 is 1/2. Cos of 45 is root 2 over 2. Plus cos of 30 is root 3 over 2. Sine of 45 is root 2 over 2. And then you just multiply. The problem is people get to sine a half all the time. I see it all the time. Okay, don't do that. So now when you multiply fractions, you multiply across the top, across the bottom. So I'm going to get root 2 over 4. Plus, what's root 3 times root 2? What do you do when you have radicals and you multiply them? Whatever's in front of the radicals, you multiply together. Whatever's under the radicals in the radicand, you multiply together. So it would be 1 times 1, which is 1. And then root 3 times root 2 is root 6 over 4. If there had been like a 2 here or a 3 here, then you'd go 2 times 3 is 6. Root 3 times root 2 is root 6. Right? Outside, outside, you multiply. Inside, inside, you multiply. Okay? It's from grade 10. Now, we're adding fractions. If we want to add fractions, we need a common denominator. What's the great thing about the sum and difference formulas? They always give you a common denominator. You never have to make one. It's there. So you're going to go root 2 plus root 6. What's root 2 plus root 6? Root 2 plus root 6. That's all it is. You can't put them together. Root 2 is like having an x, and root 6 is like having a y. Remember your rules from grade 10. The only way you can add radicals is if they have the same radicands. So over here, if I had like 2 root 2 plus 3 root 3 plus 4 root 2, my answer would be 2 root 2 plus 4 root 2, which is 6 root 2 plus 3 root 3. I can't put these together. It's like having 2x plus 3y plus 2x. I can only put the x's together, right? It's the same rules as radicands. So my answer is going to be root 2 plus root 6 over 4. And that's the exact value. Now, what's the great thing about this? Put sine 75 in your calculator. But you're going to press the sine button. The moment you press the sine button, what do you think in your head? What mode do I need to be in? I'm typing 75 degrees. So the mode I need to be in is degrees. So that's my answer in not exact values, right? I can take my answer in exact values and see if they match. Square root 2 plus square root 6, all in brackets because it's 2 terms, divided by 4. Now everyone's like, oh, this is good for multiple choice. Yeah, they don't put these in multiple choice. They'll put it in a numeric response and they'll say, what's the exact value of this? In the form root A plus root B over C, what's the sum of A, B, and C? Or put A in the first box, B in the second box, C in the third box. So yes, you can get that this decimal is 0.95 whatever, but you're going to never get the numeric response answer, right? Because it has to be in this form. Okay. However, when you have your numeric response answer, you can walk away from the diploma being like, I am so awesome, I got that question correct. Because you can compare it to that and know that they're the same, right? So at least you can walk away going, yay, I'm awesome, or oh, try again. Yeah. Yeah. Okay. Does that make sense? It's a great way to check it. And if it is a multiple choice, if they ever do that, you could always plug it in. I just can't see them doing it, but you could. So there you go. Okay, sine of pi over 12. What is pi over 12? Go 180 divided by 12. What do you get? 15? So they're asking us to find sine of 15. Do we have to find it in sine of pi over 12 and work the pi over 12 through and everything like that? Or can we just find sine of 15? We can just find sine of 15. Our answer isn't in decimals or radians. Our answer is in exact values. It's the outside part, right? So at the very beginning, if we want to change this to sine of 15, go right ahead. Degrees nor radians, we're going to still get the same answer, right? So what can I do to get some exact values off my unit circle that will somehow form a 15. 45 minus 30. Could I go 30 minus 45? No, because that's negative 15. The last one I could go 30 plus 45 or 45 plus 30 because either way gave me positive 75. But this way I have to go sine of 45 minus 30. Or, I heard someone else give another one which is correct. Sine of 60 minus 45, right? Okay, so the subtraction formula is off your formula sheet. It's sine A cos B minus cos A sine B. This is A, this is B, right? So it's going to be sine of 45 cos of 30 minus cos of 45 sine of 30. And the order in which you do it matters because there's a subtraction sign in here. With the addition, if I would have had root 6 plus root 2 or root 2 plus root 6, it's the same answer, right? Sine of 45. I take sine of 45, I throw it behind my back, and I replace it with what? Root 2 over 2. Whatever y is at 45. Cos of 30, I take it, I throw it behind my back, and I replace it with root 3 over 2. Cos of 45, I take it, I throw it behind my back, and replace it with root 2 over 2. And sine of 30 is a half. So after this step, there's no sines or coses left. They're gone, right? I'm replacing them with values. Then I multiply. What's root 2 times root 3? Root 6. Some people want to cross multiply. You only cross multiply across an equal sign. You cross multiply across an equal sign. Cross, cross, right? There's no equal signs. You just multiply across the top and across the bottom. There's no across each other. Some people like try and cross multiply. Don't. That only happens if you have something equals something. A fraction equals a fraction. Okay? So root 6 over 4 minus root 2 times 1 is just 1 root 2. Is 1 root 2, do I have to write 1 root 2? I just write root 2? So my answer is root 6 minus root 2 over 4. Then check your answer. I always plug in the original because just in case you make an oopsie and think that like sine of pi over 12 is sine 15, it's not actually. I always put the original question in and then my answer and match them. Because if I maybe made a mistake finding sine of pi over 12, sine of 15, and it wasn't actually 15, they'll match, right? But they might not match the original. So I always plug in the original. So I'm going to make my mode be degree or radian, sorry. And I'm going to do sine of pi divided by 12. Get my answer. And then I'm going to go bracket root 6 bracket minus root 2 bracket bracket divided by same answer. So I know that my answer is correct because I matched it with the question, not with what I converted it to. You try tan 165. Actually, sorry. We'll do tan 165 together because it's different. You try and come up with what you're going to put together, though. Tan 165. Is there anything that I could add or subtract to get it? Your unit circle, are there any things I could multiply or add or what to get me 165? Yeah. You do 210 minus 45. What else? $165. Yeah. We have to do exact values off of the thing. Is there anything that adds to 165? Yeah. 120 and 45, anything else? There's one more. Yeah. Yep. It doesn't matter which version you use. All of those would work. Okay? All right. I'm going to take up the space of this. You might want to write on a side paper if you want for these two because they're quite large. We'll do both of them. So I'm going to use tan positive just so I have a plus sign in the top of my formula. Tan is harder because tan is a fraction. Tan is a fraction when you do the addition and subtraction formulas. So you're going to have fractions over fractions, which makes life a little more difficult. So I'm going to do tan of 130, 135. Why am I writing 130? That's not even on the thing. 135 plus 30. No, I'm not. I'm going to do, what did we say with the, oh, we can't do anything with 145, can we? If you can get any tans with 45s, why would that be better than a tan with a 60 or a 30? Tan 45s are ones or negative ones. So you're not dealing with fractions. So if somehow you can put two numbers together with a 45 with the tan, your life is a lot better. 120 and 45. Yeah, let's do that. The other ones would work completely, but anything with a tan 45 makes life just better. So the formula is, should be in front of you. If it's not in front of you, it's there. It's like at the top two. It's all over the place. It's on the walls. So you're going to do tan of A. So this would be A, this would be B. So you're going to go tan of 120. I forewarn you, this will take up a lot of space. Tan of 120 plus tan of 45 divided by 1 minus tan of 120, tan 45. Some errors just happen between copying the formulas down. So make sure that's not you. Tan of 120. Tan is sine divided by cos. At 120, it's root 3 over 2 divided by negative a half. I'm going to do it here. Don't do it here because we're going to use this later. I'm just showing you over here. Like I said, side sheet would make your life a lot better. Don't fill it in here. You will be using this. So tan of 120 is sine divided by cos, right? So sine is y. So it's going to be root 3 over 2 divided by negative a half, which is root 3 over 2 times 2 over negative 1, which is just negative root 3. So any spot we have a tan 120, we're going to replace with negative root 3. Any place we have a tan 45, what are we going to put in its place? What's tan 45? 1. Because it would be root 2 over 2 divided by root 2 over 2, which is 1. So anytime we have a tan 120, we're going to replace it with that. Anytime we have a tan 45, we're going to replace it with 1. I repeat, do not put it here. We will be doing work here. So if you do it on a separate sheet or squish, but not the best idea. Because we picked these ones, life is a lot easier. Had we picked the 30 and the 135, we would have like, 135 would have been okay too, because it's a 45-degree angle. What was the other one? They're all 45, so we would have been okay. This one's just a positive one. Okay, so tan 120 is negative root 3. Tan 45 is plus 1 over 1 minus negative root 3 times 1. This is where radicals comes back huge, is in this tan stuff. So you're going to have, I'm going to rewrite it as 1 minus root 3. You'll see why in a second. 1 minus root 3 over, this would be 1 plus root 3. That answer isn't wrong. That answer just won't be there. Your denominator, my goodness, that was so hard to say, will be rationalized. You won't have radicals in it. How do I get rid of that 1 plus root 3 in your denominator? Do you remember? You did this the last couple of years. Rationalize the denominator. So in grade 11 you did this. You went 1, you multiplied it by the conjugate. Remember that word? The conjugate. So instead of multiplying, if on the bottom you have 1 plus root 3, you're going to multiply it by 1 minus root 3. Why does that happen? Because it will get the radical, your middle term, to cancel. So you multiply by whatever the heck is down here, opposite sign, which is called the conjugate. And then you FOIL. When you FOIL that, your middle terms are going to go away, because here you're going to get 1 root 3, positive 1 root 3. Here you're going to get minus 1 root 3, which means they cancel off, right? And then when you multiply two radicals that are the same together, what happens? So root 3 times root 3. Root 3 times root 3 is root 9, which is 3. When you multiply two radicals together that are the exact same, you just get the answer without a radical. So like root 3 times root 3 is root 9, which is 3. Root 5 times root 5 is root 25, which is 5. So when you multiply two radicals that are the same together, you get just the number without the radical. Because root 5 times root 5 would be root 25, which is 5. Okay? So that's why why multiplying by the conjugate works. So we're going to get 1 times 1, which is 1, minus root 3, what happens? That's like minus x minus x. You'd get minus 2x, right? So you're doing minus root 3, so you're going to get minus 2 root 3. Then what's negative root 3 times negative root 3? What's a negative times a negative? Positive. What's root 3 times root 3? Root 9, which is 3. And then on the bottom, you'll get 1 times 1, which is 1. Then you get 1 times negative root 3, 1 times positive root 3. So it's negative root 3 plus a root 3. So what's x? What's negative x plus an x? 0. So negative root 3 plus a root 3, they just cancel. You get negative root 3 plus a root 3. They're going to cancel. And then what's a positive root 3 times a negative root 3? Negative 3. This is all from last year. You learned this last year. Your brain may not remember it, but you did learn it last year. And then you collect like terms. So we're going to get 1 plus 3, which is 4, minus 2 root 3 over 1 minus 3, which is negative 2. And people are like, yay, you're not done. You're very close to being done, but you're not done. That answer is correct. That answer will not be there. That answer is correct. With radicals, remember in this form, this kind of looks a lot like the answer to a quadratic formula, kind of, right? Quadratic formula would just have plus or minus some values, right? If you can take a value out of every single, it's like 3 or none. It has to come out of all 3 of the numbers or none of the numbers. So it has to come out of this one, or this one. Not the radical. The only way you can pull radicals out is by making mixed radicals like you did in grade 10. Can't. It's root 3. There's nothing I can pull out of that. But if I can take something out of 4, 2, and 2, which is a 2, I take it out. I'm going to take out a negative 2 so that I'm not left with a negative 1 on the bottom, which is confusing. So if I take a negative 2 out of 4, I'm left with negative 2. If I take a negative 2 out of negative 2, I'm left with a plus 1. Negative 2 out of negative 2 cancels. So I'm left with negative 2 plus 1 root 3, or just negative 2 plus root 3. You might think this one's horrible. This could be so much more worse. If it was like root 3s over 2s and a halves over 2s, then you'd have to put them together. It gets way uglier. Like tan 75. That's an ugly one. Okay. So let's check it out. I'm going to put in degree mode, so I need to have it in a degree. And I'm going to go tan 165. And I'm going to go -2 plus √3. Hallelujah. We did it right. If not, we'd have to erase all of that. Okay? The last one we're going to go through of this type. So we went through a sine type. Cos is very similar, right? It's just a different formula, but it's set up exactly like sine. Tan is weird because it looks weird. And then secant is just what? Some people will tell me that's cos 12 over 5 pi. No. Secant 5 pi. Let's look up here and on your formula sheet. Secant 5 pi. Secant 5 pi. Does that say, okay, I write that as cos flipped of the pi or the theta or whatever the heck that is? No. It says secant pi or secant theta equals 1 over cos theta. So if this is secant 5 pi over 12, it's going to equal 1 over cos 5 pi over 12, correct? Use your formula sheet. Use your formula sheet. So this here, I'm going to go here. So it's going to be 1 over cos 5 pi over 12. Which technically is just whatever the heck 5 pi over 12 is, an exact value flipped. Right? Because if 5 pi over 12 was a half, it'd be 1 divided by a half. 1 divided by a half, which is the same as 1 times 2 over 1, right? So technically, we're just going to find out cos 5 pi over 12 and then flip it, whatever the answer is. Because you can flip the answer, right? You just can't flip an angle. What is 5 pi over 12 in degrees? What'd you get? 75. So we're going to go 1 over cos 75. Cos of 75 is just 30 plus 45, right? So we're going to do 1 over cos 30 plus 45. Please do not be that person who distributes in cos 30 plus cos 45. That is the common error that they will have the answer to every single time. Cos 30 plus 45 is cos 30 plus cos 45 minus sine 30 is sine 45. Just fill it into the plus formula. Cos A, cos B minus sine A, sine B. So cos 30 cos 45 minus sine 30 sine 45. What do I have to remember to do, though? Because everyone does what I just did. What was on top of that? A 1. The answer to that will be there, because they'll expect that you'll drop the 1 off, or it'll just evaporate. So I'm going to be left with 1 over cos of 30 is √3 over 2. Cos of 45 is √2 over 2. Sine of 30 is a half. Sine of 45 is √2 over 2. If you just get a sine or cos addition formula one, like say it's like cos of 75 or sine of 15, thank your lucky stars, that is the easiest type you can get. Very happy. Because they could be a tan or a secant or a cos, where you just flip them, right? Not really much harder, but just oopsies can happen. So I have 1 over √3 times √2 is √6 over 4 minus √2 over 4, which ultimately gets me 1 over √6 minus √2 over 4. Correct answer, but it won't be there. Don't write here again, like I said. But so I have, this is technically, I'm just showing this. You don't have to show the step. I'm just showing it to you, though. This is technically 1 divided by root 6 minus root 2 over 4, correct? Which is technically 1 times 4 over root 6 minus root 2, right? So it's that flipped. So technically the answer is just this. I like it. It's correct. It won't be there. What are they going to make you do? Rationalize. So I'm going to multiply the top and the bottom by root 6 plus root 2. Grade 11 is very important, and so is grade 10, because all of the basics from grade 10 and 11 pop up in just all the stuff you have to do later on. So we're going to multiply this by root 6 plus root 2. Root 6 plus root 2. Okay? This 4 is outside of bracket with a plus sign. So what is this going to expect you to do? Distribute it. So you're going to get 4 root 6 plus 4 root 2. And in the denominator, you're going to have root 6 times root 6, which is what? 6. Or you can go root 6 times root 6 is root 36 if you want to do middle step, and then make it be 6, which is the same thing, is fine. Now, these middle terms should go away. If the middle terms don't go away, you did not multiply by the conjugate. You multiply by the same thing, same sign. Okay? So we're going to go negative root 2 times root 6, which is negative root 12. Positive root 6 times root 2, which is positive root 12. And then negative times a positive is a negative. What's root 2 times root 2? 2. And these babies cancel. And on the top, I'm left with 4 root 6 plus 4 root 2 over 4. Beautiful answer, but it won't be there. What are they going to make you do? Take a 4 out. And when these cancel, they all become 1s. Right? All become 1s. Yeah. And so we're left with root 6 plus root 2. Let's try it out. How do I put secant in my calculator? One over cos of whatever, right? And it's in radian mode is my original. So I'm going to put this in radian mode. So I'm going to go 1 divided by cos, was it 5 pi over 12? Yeah. Oh, it's a plus sign. I was like, what? But I just didn't type it right. Having a little bit of panic. They match. The minus sign version does not match, which shouldn't, because it's not the same answer. I had little palpitations. I was like, nah, I have to redo it. Okay? We'll go through the rest of the addition, and then we'll do double angles tomorrow. Your test for all of this, you guys, remember, is on Tuesday. Not tomorrow. Next week, Tuesday. I don't like putting them after a weekend, because then you can't really ask a heck of a lot of questions. It's on the Tuesday. However, remember the following week is your cum on everything from the beginning. Perms, coms, blah, 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 blah. So when you go to study in January, you're like, oh, I got this. I'm all over this. I'm all up in this. I don't need to review a whole bunch. I've done it 3 times. I rock. Okay. So this is the last little bit here. This is the other way they could give this to you. So they can give you the formulas that look like this. If they look like this screams that they just want you to write this together, okay? Because it says exact value, 110, I don't have either of those on my unit circle. How am I going to get an exact value? Well, I know this formula looks like a formula on that formula sheet. That formula sheet, sine, cos, minus, and the huge other hint here is I have 100 and I have 100 and I have a 10 and I have a 10. So I know this is an addition or a subtraction formula, sum or difference. So the one with the subtraction is the subtracting one, okay? So this would be an A spot, B, A, or B, A. Technically, they just have them flipped. It's the same formula though, right? So you're going to go sine of 100 degrees minus 10 degrees. What's 100 minus 10? 90, thank you. You're also helpful. 90 degrees. 90 degrees is on the unit circle. What is the answer? Sine of 90. What's y at 90? See, that's such a nice, isn't that so much easier when you've just done a horrendous amount of work up there? Like, huh? So, sine of pi over 6, cos of pi over 3. I'm just going to change them to degrees so that your heads aren't exploding. What's pi over 6? 30. What's pi over 3? 60. So that's just the sine formula again, but the addition one. So technically, we're going to do sine of 30 plus 60. What is this? Exact same answer. Okay, you're going to flip to the end of this lesson. It's an addition and subtraction and a double angle lesson. You're going to flip to the end of it just so you can go to the homework, and I'll tell you which ones to do. It's a few pages. I'll put it back in a second. Remember, if you're not doing the homework, the only person you're harming is yourself. Because this test will be scary, scary, scary. In the notes, there's also little extra questions if you feel the need. Don't cross out the other ones. They're just double angle ones you can't do yet. If you do those for tonight, that's good. Make sure you do all of your homework. If you haven't been doing it, learn how to do it. If you don't know how to do it, come in and ask questions. I'm here every single lunch. Tomorrow I'm not here at the beginning of lunch, but I'm second half because I'm supervising. There's no excuse to not be here.